IME. IME is input method editors that enable users to enter text, characters, or symbols in many languages. And it is a pleasure to be here in front of you today to introduce our project and discuss our goals. And here's our content. The first is background statistic, and next is nowadays input method editors drawbacks, and next one is our system introduction, demo, and our roadmap. So, in today's globalized world, we often communicate through text. The text involves switching between different languages and using multiple languages in one sentence. And we have a research. How many languages can you speak? We got 154 replies. Most people say that they can use 2 or 3 languages. And this is a Wikipedia page. Research Hong Kong on it. The words marked with orange is English, and the words that are not marked with orange is Chinese. We just want to indicate that in some random pages, there may be more than 2 languages in it. So we are curious about what is the speed that we try to type in this kind of page. So we make another statistic. We try to type 10 times out of 22 examples, nearly 5,200 words in 3 different input method editors. And about 30.4% of the keystroke is OST on the shift and backspace. Shift is a changing input method editors, and backspace is correcting the errors. So what is nowadays input method editors problem? The first one is users will forget to switch the input method editors, and they need to spend more time on switching and correcting. And second problem is we have a communication with our foreign friends. They say they usually use 2 different input method editors. One is their native language, and another one is English. So we think that if some users need to use more than 2 different input method editors, they need to make additional choice or waste more time on switching the input method editors. So based on the previous problem, what is the satisfaction with current input method editors? And we got nearly 2.9 out of 5 points from our 154 replies. And the second question is, what is your interest in new input method editors if it doesn't require the switching action? We got 4.5 out of 5 points from 154 replies. So our goal is trying to create an input method editors that can save time, reduce error, and improve the user's experience. Second is there's no extra time for users for correcting the errors. And the users don't need to change the input method editors again because our system can automatically detect. And third one is improve the user experience. The users may feel annoying if they're trying to recognize that when they should change the input method editors. And we believe that with our system, the users can get a more smooth typing process. So here's our solution. This is our test setup, mixed with Chinese and English, and it's totally 22 example sentences. It's our comparison. The right-hand side is our solution, and the left-hand side is nowadays input method editors. You can see that the time speed, total keystroke, and backspace count in our solution is faster and less error compared to nowadays input method editors. And the most important is shift count. In our solution is 0 time. The shift count is changing the different input method editors. Here's our system introduction. Our system can support more than 3 different input method editors simultaneously, and now currently supports COMJ, Zhuyin, and English. There are our system features. We're going to introduce each feature individually in our demo video. And here comes our demo video. The first one is runtime prediction. We'll generate results when users type in if users the menu. And second one is typo correction. If the users type in error, we'll give users correction or users need. One is choosing menu, or this to recommend this word for user if they want to choose the words. Let's make a comparison. The top of the screen is now the input method editors, and the bottom is our solution. You can see that users type faster in our solution. More faster. And in the nowadays, the meta editor still become backslash count and shift count is bigger than our system. And also the time span is lower than our system. And potential of supporting multilingual language. First is pinyin, and second one is timeless language, and third one is fitness language. You can see that in our system, we can detect any language. So we just want to select our system, the result, our system can potentially support any languages if we got the role of the keystroke. And my teammate Jason will going to represent the rest of the slides. Thank you.
Okay, so now let's look inside the black box to see how we made this multilingual IME. Okay, so this is our system flowchart. We first capture users' input keystrokes from the Chrome extension, and we will go through a search algorithm, and we will discuss it later. With that search algorithm, it will go through this possibilities of guessing what users might be typing. And based on that, it will go through a scoring function of this. For the results, we will go through a scoring function based on the distance of our guess with the users typing keystrokes and the frequency of using that word. And with that scoring function, the results will be this go back to a Chrome extension so users can interact with them. So we first collect a lot of word data set, either from Chinese, from Kanji, from Zhuyin, and from English. So we will need a relationship between the keystrokes and the mapping keywords or mapping words and the vocabularies, and also the frequency of using that word. So like we have collect data from the Kaggle with English, which give 1/3 of median most used English word on the web. So with that, we have the keystroke and the mapping vocabulary and the frequency of using that word. We can convert it into a JSON file. And based on that JSON file, we can create a new data structure called child data structure. It's basically just a tree data structure, but with each link linked by a character. So that when user is typing STV and a space, we can know that user might be typing this Chinese character. And when user typing SOUP and we know that user might be typing soup. So with the child data structure, we have go through a distance algorithm, which will give to search all of node to know like what the distance between users typing keystrokes and the current node. And about the scoring function, we are currently using a type 1 scoring function, which basically just sort by the distance first, and second sort by the frequency of using that word, which will sort of sort the homophone problems, which is commonly seen when you're typing in Zhuyin, like when you're typing for 城市 meaning city, or you're typing for 城市 meaning program, which give the same typing keystroke like this one. So, and the type 2 scoring function, which we are still developing, which will more normalize like the edited distance and word frequency, and also the relation between the previous word. So, which will be more generalized and suitable for supporting more languages. So, about our roadmap, in the short term, we want to make it open source, and it is already published on the GitHub. So, we can establish some goals and like make a lot of talented programmers to help us with our project. And about some small modules that we want to develop, like we have optimized our algorithm, but also want user define their own dictionary, and also we can learn from users' typing habits. And about supporting more languages, because our goal is to make it like a multilingual IME, so we want to support as many languages as possible, which means that we will need a lot of data sets and data about the words and their rules about their language. So we will need to collaborate with some language research team. And about the AI, the long term, we also want an AI integration, because we believe that when you are typing, the previous context of the word is relevant to what you are typing in right now. So they can help us predicting with more accurate results. And also about the cross-platform support, we also want to make it you can use it on like your on a computer, like your default Windows system, like a IME, and also maybe you can also use it on your Mac. And about helping, maybe we can also develop into a cell phone devices, so you can use it on your cell phone. And this is end of our presentation. Thank you for listening.
Thank you. It's a good job. And